Alright, this problem I'm going to show us how to do an exponential modeling problem as well as we're going to have a little bit of solving. Now what's going to happen. So a doctor measures an astronaut's pulse rate y in beats per minute at various times x in minutes. After the astronaut has finished exercising. I kind of read that weird, whatever. The results are shown in the table, so I have a table of values down there. Use a graphing calculator to find an exponential model for the data. Then use the model to find how many minutes it takes for the pulse to be 52. That should be beats per minute. So we have to come up with a model, and then we're going to use it to figure out how many minutes it takes for the pulse to be 52 beats per minute. The important things I see here is exponential model. That kind of tells us what we need to be using when it comes to the calculator. So first thing I'm going to do is when I have a table of values, which is already labeled minutes x, pulse rate y, is I want to enter that data. So if you want to do that, what we're going to look at is we're going to use the stat button because we want to enter data. Table's not going to let you enter data. You can try all you want, you're not going to be able to enter this data. We're going to go to stat, and we want that first option, edit. And what I did, and I already did it to save some time, is I took all my x values and listed and put them in list 1. And then I put all my y values in list 2. Now when you do this, you want to make sure you're very careful with entering the data. Try not to go too fast, because if you make a mistake, one tiny mistake in here which you may not notice, it'll screw up the entire problem. So I have my x values in list 1, y values in list 2. So what I want to do is I need to calculate what my exponential model is. So what I'm going to do is I'm going to go back to stat, and I have options at the top. I can edit, calc, tests. We already edited and put in data, so now we want to calculate, so I'm going to arrow to the right to the calc list. And what we're looking for is we want to find exponential models. So as I go down here, I see linear, quadratic, cubic, quartic, linear again, natural log, which we're not using that in this one, but it's just good to point out. And then next we get exponential, EXP. So I'm going to hit enter. And what's going to happen with your calculator is it's going to ask you for the x values and the y values. Now by default, it's already going to put L1 and L2 there, so there's not a whole lot you need to do. Frequency list, we're not going to deal with that. Storing it, we're not going to deal with that. So I'm going to arrow down to calc and hit enter. Now our calculator is going to give us a few things here. First thing it's going to do is it's going to tell you, hey, here's the base equation we're going to use. So I'm using y equals a times b raised to the x. And then it's going to tell me what to fill in for a and b. So I'm going to rewrite but plug in for a and b. So I'm going to have y equals, for a, we're going to have 153.07. And then for b, I'm going to have 0.934, and this is raised to the x. So that would be the first part of this question. Use a calculator to find an exponential model for the data. Done, have that. The second part says then use the model to find how many minutes it takes for the pulse to be 52. So I want to figure out, what is this 52 represent? Is that x or is it y that I'm plugging in for? Well, since they're giving me a pulse rate, 52, that is y. So I'm plugging in for 52, so I'd have 52 is equal to 153.07 times 0.934 raised to the x. And they want to know how many minutes, and remember that's x. So they want me to solve for x here. So what I have here is actually an exponential equation that I need to solve, but it's a real-life model, so there are decimals there. We can do this though. We would like to solve for x and get x by itself. So kind of going back to our solving exponential equations videos and all that, going backwards in order of operations. So if I want to isolate x, I have 153 times this base attached to that exponent. So I want to get rid of this 153 first. So since it's 153.07 times something else, the inverse would be dividing by 153.07. And I'm going to do that on both sides. So you take that and you get, I just did it on my calculator off screen. I'm going to round here. Let's call that 0.340 is equal to 0.934x. So I just have to solve there for x still. So I got a base attached to this exponent. I need to get to that x value. To get to that base, what I'm going to do is use an inverse. Again, the inverse of that base of 0.934 is a base of log base 0.934. But here's the deal. If I do it on the right side, I have to do it on the left side. Log of 0.934. The reason why that works is when you have a log base and an exponential with the same base, those are inverses and that's gone. So I have x, and on the left side I have log base 0.934 of 0.340 is equal to x. So to solve this, that's not really exactly pretty, but we could do this on a calculator. To figure out what x is, so I just took that and flipped it on the left side. I'm going to use the change of base formula, so that 0.340 is towards the top, so I'm going to take log of 0.340, and that 0.934 is located towards the bottom. That's going to be my bottom, divided by log 0.934. So I'm going to type that in a calculator. So I'm going to have log of 0.340 divided by log of 0.934, and I get 15.8, which in the context of the problem, that's 15.8 minutes. So it's going to take 15.8 minutes for this astronaut's pulse rate to come down to 52 beats per minute. So that is exponential modeling, and that concludes Chapter 6 videos.